Hello everyone, I hope you're doing well. So in this video, we are going to discuss Geeks for Geeks problem of the day, and today's problem is maximum number of coins, and it is a hard level problem. So this particular problem says that we have been given n balloons or n items, and each of it has certain number of coins associated with it. So if you burst the ith balloon, the number of coins gained is equals to ai minus 1 multiplied by ai plus 1, right? Also, the balloons I minus 1 and I plus 1 now become adjacent, right? So, whenever a balloon is burst, there is a certain number of points that are added to our answer, and that particular balloon is removed from the sequence, so that the I plus 1 and the I minus 1 balloons become adjacent. Now we have to find the maximum profit earned after bursting all the balloons, and it say that we can assume extra 1 at each boundary, so that like for the first index, when you try to calculate ai minus 1, it's always going to be 1, and for the last index, if you try to calculate ai plus 1, it's always going to be 1. That is why they have added this particular state. Now this particular question is a classical DP problem, and as you can see by the number of submissions, the problem statement is very straightforward. It's just that it's like not very intuitive to think of. First of all, we'll discuss how this particular test case is working. So although they have explained it in the test case only, they've written it like the explanation. So for example, if 3158 is here, we have to assume 1 and 1 here, right? So they say that we have to first remove this particular 1, and the answer would be 3, that is ai minus 1 is this one, ai plus 1 is this one. So the total product will be 3 into 1 into 5, right? So this is 15. Now if we remove it, what will happen? This will be removed. Now they say the next number we have to remove is 5, right? So ai minus 1 is this, ai plus 1 is this. So the product will be 3 into 5 into 8, that is 120, right? Now I remove this 5. Now they say the next number that we have to remove is 3. So if you remove 3, then ai minus 1 is this, ai plus 1 is this. This will be 1 into 3 into 8. This is 24. Now the remaining element is 8. So the product will be 8 itself. 1 into 8 into 1. If you add all of these, this will be equals to 167, and this will be the explanation of this particular test case, right? So you like if you take any other order or any other sequence, the answer will never be 167. It is going to be less than, until unless you are removing the same elements. For example, if this is the sequence, no matter what order you take, the answer will always be the same. But in a general case, the maximum answer should only be possible if you follow one particular sequence. Now the intuition for this particular question is a bit tricky. So for example, if you have these elements in front of yourself, so the elements were 3 1 5 and 8, 3 1 5 8, and there is 1 on both sides, right? Now it is very difficult for us to calculate which element I want to remove, because if you want to remove 3, right now you can see that there is 1 this side and 1 this side, right? But for example, this one was already removed, then you will have to again calculate that no, there is not 1 here, there is 5 here, right? For example, if this 5 was also removed, you will again have to calculate that there is 8 here, right? So this is not very ideal to calculate which element I want to remove. So we will think of a counter approach, right? We will think the question in opposite direction. So for example, if I have been given a range, if this is my range, right, I'll assume that there is only one element left, right? When I assume this particular thing, that there is only one element left in between, it is very easier for me to calculate the answer. I'll explain you how. So for example, if I assume that only 5 is left and these elements are removed, so let us assume that these elements are no longer in our input, right? So I assume that only 5 is left, right? I know that on this end 1 will be there and on this end 1 will be there, right? So I already know my answer, that it will be equals to 1 into 5 into 1, right? If I assume that in the range 1 to n, 5 is the only element remaining. Now how do I calculate the answer for the remaining elements? I can do the same thing. I have got a second range like this. Now this is my new range. In this particular range, I can again assume some number which is the last element remaining. So for example, in this range, if 3 is the last element remaining, then I already know the answer would be 1 into 3 into 1. Right? Again, I can divide this thing into two ranges. Right? So this is how we are breaking our problem into simpler sub problems, and you must be getting an idea of how the recursive solution would work. So the DP states would be DP of ij, right? So I from I to j is the range that we are calculating, right? I to j is the range we are calculating, and for each range we will calculate what is the last element. Last element we want to remove. Last element we want to remove. So this is not the answer. This is what we are calculating, right? This is what we are calculating at dp of ij. So dp of ij, whenever we are calculating the answer for this particular range ij, we would want to calculate the last element that we want to remove in that particular range, in that range, right? And for this, we can just like linearly go through all the elements and try removing each of them. Since we will form one loop for I, one loop for j, and one loop for k, in this case we will choose our element that I want to remove the kth element, right? So the total complexity would be n cube, and that is the expected time complexity of the given input also. So we want to remove the kth element, right? So whenever we remove the kth element, we would already know that the answer would be, so for example, if I remove the kth element and I have assumed that all the other elements have already been removed in the range I to j, right? So my answer would be v of k. For example, the a is the input, v of k into a of I minus 1. Why I minus 1? Because all the elements after I have already been removed from I to j. Similarly, a of j plus 1, right? So this would be the multiplier that I have to use, because all the elements from I to j have already been removed and k is the last element that I was trying to remove. So I already know that this will be the multiplier that I have to use. Now I'll have to add something to my answer, and that will be dp of I to k minus 1 plus dp of k plus 1 to j. So I've decided that this will be the last, that the kth element will be the last element to remove. If I have decided that in the range I to j, k is the last element that I want to remove, that I can certainly decide that the value that will be added to my answer after removing the kth element would be this, right? This is for certain. Now if I am removing the kth element, what about the other elements in the range I to j? Again, I can recursively do the dp thing, that I want to calculate dp of I to k minus 1. So for example, if I is here and j is here and I want to remove some element k from here, right? I can recursively calculate our answer for this and then the answer for this, right? So this way I'll be able to calculate all my answers. Again, in the range I to k minus 1, again I'll choose an element which I believe would be the last element to remove, right? And among all the occurrences, I can take my answer. So like doing this recursively is a bit simpler than doing it in the tabulative form. So we are going to discuss the tabulative form now, but I'll just give you an idea of overview of the idea how the recursive approach works. So since you have already calculated all of these things, in each of the range I to j, you have to do this. You have to choose a number k. For example, the initial range would be 1 to n. You have to choose a number k in between. You can use a simple for loop to choose this number k between 1 to n, and once you have chosen that number k, you have to, you know that this is the value that you have to add to the answer, and you can recursively call your function for the new ranges I to k minus 1 and k plus 1 to j, right? You have to recursively call the function, your same function on these two values. So this will be the new values of I and j respectively. And when you do this recursively, you have to save the answer, or you have to do memorization for dp of ij, where I and j would be the ranges respectively, right? So this is the simpler recursive approach that you have to form. Now the problem with tabulative approach is this, like, it is not very difficult either, but the only thing is we have to think before writing our code, because there might be some cases, like for example in this particular case, if you want to calculate the answer for I to j, then we already need to know the answer for I to k minus 1 and k plus 1 to j. What happens in recursive form or recursive memorization, everything is computed like on the fly. But in tabulative form, we have to pre-compute, we have to make sure that this value is computed before computing this particular value for I to j, right? So I'll give an example. It will help you like to understand in what order should we follow the for loops so that we get a correct answer. So for example, if I and j are like this, right? So let us assume that we are following this order: 1 1 1 2 1 3 1 4 1 5. This is the order of I to j that we are following. This is a simple for loop that we can construct, right? But if, for example, if I want to form the answer for 1 to 6, right? Let us assume that the I is 1 and j is 6. We want to form our answer for this. Now let us say that k is something like 4, right? Can we compute our answer for this? The answer is no, because to come for this particular value I to 6, if I have chosen my k is equals to 4, I already need to know the answer for 1 to 3 and 5 to 6, but I have not computed it yet. I have computed 1 to 3, but I have not computed 5 to 6. So this is the wrong approach for I to j to work. Now a second approach, like a second series, what I can form is, you can do only two things. Either you can form from the starting, or you can form from the back, right? So now we will try to form from the back. So let us say n is equals to 10. So let us say that this is 10 10 first, and this is, then it is 9 9, then 9 10, then let's say 8 8 8 9 8 10, then 7 7 7 8 7 9 7 10. So I hope you're like getting the pattern that I'm trying to form here. You can always form this pattern easily with for loops. So for example, now I is 7 and j is 10, right? You want to form the answer for this particular value. Now if let's say I take k is equals to 8, so for k is equals to 8, you already need to know the answer for 7 comma 7, for the range 7 comma 7 and 9 comma 10. Do we know the answer for these two ranges? Yes, we have calculated 7 comma 7 previously. We have also calculated 9 comma 10 previously, right? So any example you take in this particular pattern, you will find that for all values of I and j, you would have already calculated the values for all k, such that I and k minus 1 you have already calculated, and k plus 1 till j you have already calculated, right? So we are going to follow this particular pattern, and this particular pattern will only give our answer. If we try to form our for loop like this will lead to an incorrect answer, as we have already seen that we have not calculated 5 to 6 earlier, right? So let me just quickly go through the approach quickly once again. So we are going to use dp. Now we have found out that if we try to like take the element first and then try to calculate what will the further possibilities, it is very difficult to find the correct answer. So we assume that we are taking an element k which will be the last element to remove. When we assume that the current element would be the last element to remove, we would already know what will be the answer that, or what will be the value that it will contribute to my final answer. Because if it is the last element to remove and I know the range in which it is the last element to remove, I can multiply it by the opposite end of the ranges. So I decide that in any range I to j, I will take the last element that I want to remove after all the other elements have been already removed. So if in the range I into j, I comma j, I want to remove an element k, so the total value that it will contribute is a of k into a of I minus 1 into a of j plus 1, right? If in the range I to j, I want to remove the kth element at the last, the total value that it will contribute is a of k into a of I minus 1 into a of j plus 1. Now there is also some other contributions in this particular range when I choose this particular range. So the other will be dp of I to k minus 1, right? So this will be the, when I remove the kth element, I will recursively calculate the same answer for I to k minus 1 range, and I will again calculate the same answer for dp of k plus 1 to j range, right? So if you're forming a recursive memorization solution, then this is the only thing that you have to do. You have to recursively call the same function. For example, you have a helper function at your help. So if you use the helper function, you can again call it for this particular value. For I and j, again you can call it for this particular value, right? So this is very simple. But now if you want to like find the same answer using tabulative form, it is a bit like it is not difficult, but you just have to think a bit more about how you will exactly write the for loops, right? So we have discovered that like in any DP problem you have already two or three like cases on how you will write the for loop. So the first one is to start from the front, right? Start from the beginning. So I tried writing some sequences 1 1 1 2 1 3 1 4 1 5 1 6, and we have found that if we take any general value, for example we had taken 1 6, and we take a k between them, like for example 4, then for 1 6, for I and j is equals to 1 and 6, and for k is equals to 4, we already need to calculate the value of dp of 1 3 and dp of 5 6. In this particular case we have calculated dp of 1 3, but we have not calculated dp of 5 6, right? So this would lead to an incorrect answer, since we have not already calculated the dp values on which our current answer is depending. So the primary constraint for tabulative form is that if you want to write your DP problem in tabulative form, you need to pre-compute the values on which the current value is depending, right? So we form another approach from the back. If try to traverse from the back, so what we do is we start from 10 10, then we go to 9 9 9 10 8 8 8 9 8 10. We go in this particular manner, and we just stop at a random place. I take I is equal to 7 and j is equal to 10. I take a random k between them. For example, k is equal to 8, right? So in this particular case, we were able to find 7 7 and 9 10 both in our pre-computed values. So for I is equal to 7 and j is equal to 10 and k is equal to 8, right? We wanted the value 7 7 and 9 10 to be pre-computed, and here we can see that we have already computed 9 10 and 7 7 both of them. So this is the only way we can reach our final answer. So we will use this particular for loop pattern to form our answer, right? So let us have a look at the code quickly. So I have initialized my vector of size n plus 2 here, because I wanted the 0th index to be like and the n plus 1 index to be 1, right? Because these are the two ends of our ranges, right? So after that I copy all the remaining values into my vector, and I have initialized a DP vector of size n plus 2 cross n plus 2, right? So now I just start my for loop from n till it is greater than 0, and the second for loop will start from I itself and till it is less than 1. So it will form the same pattern that I just shown you a while ago, and I've initialized my cost with 0. So this is the total cost of in the range I and j. Now I just try to choose the last element that will be remaining in the range I to j, right? So I'll for each of those k, I'll just do this is the value that it will contribute to my answer. Since I've already removed all the elements in the range I to j, my v of k is the current element, my v of I minus 1 is the element left to it, and v of j plus 1 is the element right to it, right? Now if I have computed the answer for this, I'll have to recursively compute for the left range after removing the kth element, and for the right range after removing the kth element. So the left range is dp of I to k minus 1, and the right range is dp of k plus 1 to j, right? So if I am assuming that k is the last element that I want to remove in the range I to j, I have to update my cost as max of cost comma current cost, and dp of ij will store the maximum cost of removing like either one of those k elements. So among all those k elements, the last one to remove, I'll store the maximum value among those, right? And again, after I have computed all of these, at the end I can just return dp of 1 to n, because this will store the answer for the whole range. So this was the solution for today's problem of the day, maximum number of points. I hope you guys were able to understand the solution. If you guys did, then you can consider dropping a like on this video, and don't forget to subscribe, since these videos are always free. And in the future, if you don't find these videos helpful, you can always unsubscribe later. So till the next video drops, keep coding, stay safe, bye bye.